right, so we're going to talk about day 9 notes. The goal of today's lesson is to predict without graphing the behavior of graphs of the pieces in relationship to another. There are 3 different scenarios that can occur, and we're going to draw an example of each. So the pieces can connect. So we're talking about different types of functions, but the pieces can connect at a closed circle at x equals a. So let's say that I've got a piece here that goes down, and then I've got some sort of graph here, and they connect right here at x is equal to a. Then the pieces can connect at an open circle. So let's say that I've got this situation going here, and you can see that there's an open circle when x equals a. And then it says the pieces cannot connect with each other at all when x is equal to a. So that means that we've got at x equals a, there's an opened, or maybe there's a closed, and then we're doing this kind of a thing. So these are the 3 situations that can happen, where you have a closed dot that connects them, an open dot, or when they're not even touching. So the latter two of these 3 scenarios are examples of functions that have discontinuity, all right, which means they're discontinuous. Before we take a look at graphs that have discontinuities, let's investigate one function in which there is no discontinuity. That is a function whose pieces connect at a closed circle. So here we have a piecewise graph, and let's go ahead and graph it. It says the first piece of the graph of q of x will end just shy of x equals, and let's take a look and graph that. We know that according to this domain, this parabola only exists from -5 to 0. So when x equals 0, that's where it's going to end. But the second piece is going to begin at x is equal to 0. So what we need to do is q of x defined at the x value where the first piece ends and the second piece begins. If so, find the value of y at that x value. So what we really need to do is we can go ahead and graph. We know that the vertex is left 3 and up 4. We've got a downward slope, so that's 1, and then now we're going to go 1, 2, 3 over 1. 1, 2, 3 over 1, and then down 1, 2, 3, 4, 5 over 1, and it's open. So there's my parabola. It does not have arrow tips because it only works when x is 5 to 0. Then there is a V where the vertex is at 2, -7, and it has a slope of 1. So I'm just going to that way have the arrows, and again it starts at 0. Now remember that this one was open, but it looks like they begin and end at the same spot. So even though this is open and that one is closed, we still need to close it. Okay? So q of 0 is equal to, we need to plug it into this function. 0 minus 2 minus 7 gives us 2 minus 7, which is -5. Okay? So the y value, and of course we could graph it and see that the y value is -5. Complete the following statements according to the graph. Now this is red. As x approaches 0 from the left, which means I'm on the left side of 0. So the left side of 0 is on this picture, on this piece, and the y value on this side of 0 is -5. And this means, when the positive means from the right. So I'm coming from the right, okay, and I'm going to get to 0, and the y value on this side is negative 5. So it says, using the equation of q of x, determine the y values that each piece approaches from the left and the right of x equals 0. So here's what we're going to write. So it says, as x approaches 0 from the left, q of x, that means I am in this function right here, 0 plus 3 squared plus 4 gives me negative 3 squared is 9, negative 9 plus 4 gives me negative 5. As x approaches 0 from the right, q of x, and then I'm going to be using this function, 0 minus 2 minus 7 is equal to 2 minus 7, which gives me negative 5. Since both can't spell, pieces approach the same y value, okay, they both approach the same y value of negative 5, and q of 0, when I actually plug in 0, I get a distinct y value of negative 5, then q of x is continuous at x equals 0. All right, so we're going to talk about continuity.